Hi everyone. Thank you for being here. We'll be speaking English today for this first workshop and seminar of the university year in for Victoria. So thank you very much for everyone online and here for being here. We are really glad to have two people speaking today. Lauren Tilton, who is a professor of digital humanities at the University of Richmond. Her research explores the use of digital and computational methods to study 20th and 21st century documentary expression and visual culture. She co-directs the Distant Viewing Lab and has co-authored several notable works. I will be speaking of them a little bit after that. She will be speaking with Taylor Arnold, who is a professor of data science and statistics at the University of Richmond. His research focuses on corpus-based techniques to study visual and multimodal communication, and he has also co-authored human data in R, and the work he co-authored with Lauren, Distant Viewing, Computational Exploration of Digital Images, and works on integrating data science with the humanities. And he also co-directs the Distant Viewing Lab, which we will be talking about today. So thank you very much for them for speaking today. And they'll be giving us speak, and then they will be doing a workshop, and there will be another workshop which will be organized by Salim Aïssi, who is a PhD candidate at the Institut des Systèmes Intelligents et Robotiques de Paris, whose work centers around computer vision and natural language processing, focused on intelligent system can interpret and interact with visual and textual data. So thank you so much for them for being here. I will immediately give them the, yeah, you can talk. Yeah. Okay. Thank you again.
Thank you. Awesome. Okay.
So yeah, you can.
We'll drive from this one.
Yeah.
Okay. Awesome. Great. Got it.
Yeah.
Okay. Sit, I'll stand, or how do you get this fine?
So your presentation is here.
Okay.
I think it's better. Yeah, no, it's all right.
Okay.
All right. Doesn't hold. Yeah.
Okay.
Thanks.
Okay. That's so bad. Want to stand or?
We can try it.
I'm a stander, but that's okay.
We can
I'll stand. We'll see. Okay. Okay, cool.
I'm just tall.
Yeah, that's fine. Thank you all so much for having us join today, and thanks for listening to us in English. So appreciate that. It's a real delight. We heard about Pictoria AI at a conference with Clarice Bardio at Rennes, and heard about this amazing set of works happening. So it's a real delight to connect with the community here. So thank you for the invitation. And one note is that at least I can be super American and talk very, very fast. So I invite you to be like, okay, thank you. It's kind of a feature of mine. So a little bit to get started here is about our lab. We develop computational techniques to analyze visual culture on a large scale and develop tools and methods and data sets for that kind of work at University of Richmond in the US. So that's sort of the scope of our work there. So today we're going to talk a little bit about how we're thinking about distant viewing.
Yeah, so we'll start with just a really quick overview of the theoretical part of distant viewing. And then we will explain a historic photographic corpus. One example is here on the right. And then we will actually explore a few different techniques for enabling access and discovery and search of photographic collections, with this specific one as an example. And then we'll actually see some new distant viewing approaches that we've been using more recently, and then see how those approaches connect back to the theoretical states that we started with.
Great. Okay. And just to note that if you're interested in some more about some of the concepts and theories, this is the book that some of this work is based on. It's open access, so you can just download it. So for as you wish. And then also some of the work today expands on this book. So we're hoping that. So a little bit about the theory that we have been working on with distant viewing.
Yeah, so when we say distant viewing, we specifically mean a theory of how the computational exploration of digital images through the application of computer vision, which computer vision, we just mean any algorithm that works with images, how it works and why it's needed. And it really has three parts. The first is that the mimetic nature of images necessitates that we start our computational analysis with some sort of extraction of semantic metadata using computer vision broadly defined. So for example, on this image, we might find the dominant colors. We might say that it's indoors. We might say how many people there are. We might tag what the objects are in the frame, and on and on. We can do a lot of different things with it. The second part is that we really think of this process of going from the pixel, the digitized image, to the structured data as a computationally mediated form of viewing, which we call distant viewing. And then the last part is because of parts 1 and 2, the application of computer vision is not a neutral process, and it engages in all the socially mediated ways of viewing and seeing that are encoded by both the algorithms and our choice to use them on these collections.
And so the idea behind this is to bring together media studies, visual culture studies, and theories with knowledge of how computer vision works. So what we did was, we're going to talk today is about some approaches for doing distant viewing that, and we're going to center around 4 ways that we've been thinking about it around this collection called Documerica. So in the 1970s, there was a new agency in the US called the Environmental Protection Agency. It rose amid the environmental movement. And what they did was Documerica hired over 100 photographers to go across the United States and document the state of the nation's environment. Think trash dumps, oil slicks, waste water going into drainage, nuclear power plants, all of these elements. They took over 16,000 of these photographs are digitized. There's another probably at least 20 or 30,000 that have not been. And it's modeled on the famed FSA collection. So this is the same people, Arthur Rothstein and Roy Stryker is involved. These are the people who created some of the most iconic photographs, Dorothea Lange, Walker Evans. They were all part of the FSA in the 30s. This is modeled on the FSA, but it's supposed to be an environmental version. So we were interested in how could distant viewing helping us think about this collection. And we're going to look at several approaches that have kind of been the first 3 are sort of kind of classic approaches, if you will.
Yeah, it's a bit of a joke for humanity. It existed in 2020.
Yeah. So it's a bit of a, for our historians in the room, it's more fun. So
yeah, so one approach, and this one actually existed even earlier than that, like 2010, is we can just use the metadata. So we can open up search and discovery through the metadata, really carefully archive materials like when was it taken, where was it taken, by whom was it taken, and then we can have search and discovery just on those metadata categories. So for example, here with Documerica, these 5 photographs, 5 over there. 5 photographs were all taken by the same photographer in the same place at the same time as the one that we saw there.
And so this kind of a metadata approach, y'all probably really used to. It can be really kind of easy to integrate into a public interface because we usually have really good, like someone's created that metadata, such as the place, the location, and often there's kind of gold standard examples around that. It can be has a lot of explainability, place, location. We know why we have that metadata, that information about it. And it can sometimes avoid some difficulties with archives and other elements. Some of the challenges can be that working with collections to think about how do we open them up for access and discovery. If you're relying on metadata, it means they need those descriptions. It needs that textual descriptions, and lots of images do not have textual descriptions or have very little of it. And sometimes the metadata can be super granular or specific, and it can take a lot to unpack why the metadata about that collection looks the way it does. And often it doesn't always include the actual visual components of the image. So one of the ways that we used the metadata was to build this project called Photogrammer. So we used the location information, the photographer information, and their dates to create a faceted search interface experience that you can now explore the 170,000 photographs from the FSA in that way. But this is just solely built on metadata.
So the second approach is, and this is, I think, what most people think of when they think of computer vision, is to use supervised machine learning to actually have extract specific tags. So for example, give me an image and let me identify a certain set of objects from some particular lexicon. So here, for example, you can use an object detection algorithm and detect that, oh, look, there's a bottle. You could also find faces and people, things, and then you could use those much the way you would use with the archival metadata for search and discovery. So here, for example, are 6 images that all also show bottles, and they show the variety of different ways that bottles can show up, different kinds of bottles, in different ways in this collection.
And you can also think of this as a kind of a way to do thematic searching. Say you're interested in a particular topic in a large collection, you're a scholar of technology, or you're interested in environment. There's other ways to think about that as well.
Yeah.
So some of the advantages is that when you have a collection, regardless of size, you can use these machine learning algorithms to annotate in specific ways that allow us to look, say, for example, at bottles, as you see here from the Documerica collection. Some of the challenges is that a lot of these are out of the box, they're trained, and they don't always work well with other inputs. You can do some of your own training, but that has, and there makes possibility, but that adds a lot of time. Sometimes the tags don't always align with what we're interested in, and creating new models can be quite difficult. So, and you can be restricted to some of these terms. So that is a challenge that can be a part of the equation. So in our case, what we did, we've often supervised people in viewing and in articles, but we actually didn't do it with Photogrammer, the more public digital humanities project, because we couldn't always know exactly what was connecting to what and how to.
They're very good for like looking at specific things, like where is the face in the frame and understanding how that shows visual intimacy. It was great for a research project, but it doesn't map onto very well what might be of interest to a broad public.
Yeah.
And then the third technique has actually been very popular in the digital humanities community. That's image embedding. And so this is where we take an image and we associate it with a sequence of numbers. And the sequence of numbers, the individual numbers don't have any real meaning, but the point is that 2 images that have similar visual features will have similar sets of numbers. And we can use that to enable search and discovery. And then actually this is related to the first technique, because usually what you do is you take a deep learning model, which has been built to detect bottles or bananas or couches, something on the right here. And then the reason it's called deep learning is it doesn't go directly from the image to the predictions. It goes through lots of intermediate steps. Turns out if you look at like one of the later steps, like in here, you can actually look at those numbers and they kind of have some meaning about shapes and general things, not specific to the specific objects that it was trained on. It's not perfect, but it does some interesting things. And here, for example, are 6 images that are the most close, have the closest embedding to the one that we started with, the man bottling the milk bottle.
And so these are cool because you can, you don't have to have like direct metadata, you don't have to have direct supervised methods, but one of the challenges, and so it can build connections across a collection that you may or may not have thought to look for or even imagined. And it can be really great for adapting across different collections as well. But one of the challenges is explainability for this. Exactly why is it making the connections it's making? In this case, I would argue that's probably something to do with the way that the light in the background is putting a certain set of people in focus on some sort of, as you can tell, kind of at the first one where it's sort of the lights in the back window and it creates like an angle across. And there's something about the way it looks like a spotlight coming in, but we don't exactly know. I'm making that assumption as a human reader of images. And it can also sometimes create problematic or odd connections. There's kind of a famous case of this when Google Arts and Culture released their some like image similarity algorithms that put people's faces together with problematic topics and other art problematically together. So explainability becomes really important when you're thinking about comparison and similarity with these kinds of methods.
Like here, for example, if you're a dairy farmer, you probably don't want to be connected to a
radioactive, toxic, radioactive. So well, less, we have used this though. So in Photogrammer, what we did was when we first started Photogrammer, the image analysis, computer vision was not very good. for a series of reasons. And this has really been very cool because this has let us build a recommender system or set of connections in the collection that allows for comparison. And what you will notice on the far right is that those are two images that have no metadata. There's no information about the photographer, place. The only way that image is being shown and recognized is because it has some visual similarity to the other image. And when this scales, so in this particular, the FSA collection, the farm security, there's about 40,000 photographs that have no metadata. There's no description. All you have is visual. So these become methods to open up the collections and see them in ways. The only way you'd even be able to find it if you went to Library of Congress is to know its exact hall number, LC dash something. So one of the things we've been thinking about is those are sort of the three kind of primary categories of distant viewing that we had been working within. And of course, as we all know, LLMs have changed so much in the last year or two, and I don't want to be too much of a technological progress and narrative, but I think that the LLMs have really changing how we think about things.
Yeah, so there's been this explosion of LLM techniques by various companies, OpenAI, Google, Anthropic. I think Apple yesterday is now doing AI too. So that's been over the last year and a half, and over the last like 8 or 9 months, there's also been an increase of multimodal LLMs. And they're actually, when we did the research we're going to present, there was only closed source, and now there are some open source things like Lava that allow us to do that. And so let's see an example of what a multimodal LLM does. So the way that it works is that you give it an image and a textual prompt. So here we're going to go, we keep using the same image here over and over. So we give the LLM this image, and then the prompt at the bottom, provide a detailed plain text description of the objects, activities, people, background, and/or composition of this photograph. And then we get back this very lengthy LLM style description. We played around with the prompt. The first time we did it, it went through every single image and told us it was maybe from the 1970s, which was not super helpful, but I guess good that it recognized that. Yeah, so this is like a lengthy description of all of the things that it found in the image. It's not perfect, but it's pretty good. So the new approach, what we're doing with the MLLMs, is to take the images with the prompt, each of them, generate this long textual description, and then from the textual description, generate an embedding of that, which you can also do embeddings just like you do with text, with images, with text. And then also identify top terms just using classical like TF, IDF, NLP type techniques. And then doing the same things that we've done before with that embedding in the structured data. So here, for example, are using the embedding, the 5 closest images to the one that we started with. And you'll notice that this is actually, to me at least, a much more semantically interesting set. These are all different. The first 2 are other bottling plants. And then the ones on the bottom are different parts of the process of producing milk. So milking a cow, cleaning the equipment, and then packaging it. So you didn't find the other techniques at all, because visually they look very different, but there are like these higher order connections between them.
And then, you want to say
and then the other really great thing about this, which we love, is that unlike with the image embedding, we can actually say why we think that this set is all connected, because we have the captions and we can just find what terms separate these the most from all of the other images. And so here, for example, the images, the text is bottle, milk, process, milking efficiency. And it's nice because I can actually say, I don't exactly understand how the embedding works and all that, but I do know there is some semantic similarity between these, and I can algorithmically tag them.
So you go back to some of the advantages you've already been talking about. Is we actually have a lot more explainability, that we can be able to tell why these connections are built the way they are. We have a little bit more, we could filter on these terms. Once you have these kind of really long descriptions plus the images, it really opens up a sort of ability to build networks and connections between text and image in a way that we have found really quite powerful. And it works on a variety of inputs. So one of the things that we've noticed is that these are working very well because they're trained on so much data. And of course, that's a debate, right, about why OpenAI and them aren't actually telling people what they trained it all on. So that's both the challenge, but the other part of that has meant that they are very, very powerful in terms of the range of visual analysis they can do because of the way that they're not just trained on 1,000 objects in primary photography. They're trained on this incredibly large corpus that is giving a lot of power.
And then the other thing that we haven't done here, but it's very easy to implement, is that since you go from the image to the caption and then the caption to the things that you do, you can filter things in the caption. If
Yeah.
you want to get rid of any gendered language, if you want to get rid of any like racial stereotypes, you can do that kind of filtering that you can't do when you're doing visual embeddings. And that's been something that a lot of well, us too, but also a lot of our partners at libraries and archives have been very interested and worried about, rightfully so, of other methods. And while nothing's perfect, this is at least a way of avoiding it.
Yeah. And of course, there's some challenges. One is just some of the challenges that are broadly been brought up about LLMs, which are all totally fair. And then, you know, another big part about the kind of what kind of prompting you want to do. And this is where we think it really comes back to like distant viewing, right? We're asking the computer to see and view in certain ways. And the prompts are now a way that we are doing that does a visual search, which comes back to our kind of other point here thing. I'm gonna go back. Oh, sorry, I missed that part. We'll say one more thing about that. We'll come back to a larger point about distant viewing here in a second.
Yeah, and then
about that.
and then just very quickly, we have more benchmarks about how this works if people are interested in more of the details, but just very quickly so you can get a sense. This is a visualization of all of the connections. So each point here is one Documerica image, and then it's closest to the one that's the most similar to. The pink is like the old school, like 3 years ago, and the green is the new school, like 4 months ago. Method. You can really see that it's not a subtle difference. They're very, very different shape. There are much more clusters. They're much more semantically tight connections. And then the other neat thing is that also where there's a cluster, I'm not like these images look kind of similar and I have to look at them. I mean, I love to look at them, don't get me wrong. But I can start by actually labeling them and saying, this is a pollution cluster, this is an air cluster, this is a trash cluster. And then I can dig in and understand what they are. And so this is a great way of building it. We're in the process of doing it, but building a new interface that can start from the themes and then get you to the images, which is
we're building a photogrammer that's basically built around this. So, and the other thing I'll note as just a historian of photography, this is a really interesting way to think about how these categories actually don't always align with what the government agency said it was doing. So then you can see these misalignments and alignments that help open up questions about the collection itself.
So I just want to finish by connecting this back to the theoretical piece. So distant viewing. So the core idea of distant viewing is that we need to create annotations to do computational analysis, and that creation process is a form of viewing. And to us, the presence of multimodal LLMs is actually the perfect example of what we were always saying. And in many ways, it's, I don't know the right adjective, but it's like it's a more simple, concise maybe way of thinking about distant viewing, because while computers are not even LLMs, nowhere near thinking the way that we do, they're closer to the way that we think about them. We see an image and then we get a description. If you ask someone, if we went into the archives downstairs and picked up an image and talked about them, at least it would be sort of similar to the way the LLM is describing this and that and what it means. And it's just much closer to the way that we think about images. And then also the fact that we have this open-ended prompt and we can go back and forth and prompt engineer. We can ask one question and then another. Also highlights the fact that there's so much that we can do as researchers that affects the output. And then we really need to think about that as a process of viewing that is culturally mediated and important, and it really influences what we actually do. So for us, like multimodal LLMs is the perfect example of the theory of distant viewing. So in this era of them, we really just think that the theoretical stakes behind them, as well as the computational pieces, are more important than ever.
And I think another exciting is that the advances in these methods have made area expertise really important. Actually, I think there's never the opportunities to work together with folks who are experts of historians of photography and experts in other methods, when you're in medieval manuscripts or others, and then you're thinking about ways of viewing computationally, that the sort of brute force kind of method before is kind of remove that, and the nuances that people are trying to get are actually really informed by the expertise of folks who really have committed their lives in a lot of ways to knowing about these histories and their context and their provenance and other elements. So I think it's a really if we frame it in the way I think we can, it's a really exciting moment also for the humanities and libraries and archives and the expertise that comes with that to bring it together. So I think it's a really exciting moment. So thank you.
Yeah.